Hello everybody, in this video we are going to solve few problems related to the resistances in series and parallel. Excuse me, and I'm going to explain it to you that how to find out the equivalent resistance. So in this given problem there are two resistances here and one resistance here. So the easiest trick to find out is that we are being asked that find the equivalent resistance between points A and B. So what we are going to do is we are going to connect a battery across it like this. You can connect this battery in any of the order, like plus here or plus here. You can flip the terminals also. Now first of all, some current I is going to come out of the battery. You need not to assume the value of this one. Just for our own help, we are going to place the battery. It can be of any voltage, right? And we don't want to get into that how much is the current and all that stuff. So some current I flows into this terminal and A and comes till here. Then since there are two ways for the current to go, so some current I1 will go up and some current I2 will go down. And this same current I2 will pass through this, and this current I1 will pass through 6 ohm resistance, and the same current I1 will also pass through this 6 ohm resistance, and then this current I1 will come down, this current I2 will flow back till this point, and then these two currents will be added, and again it will make the same current I, and the same current I will come back into the battery. So we notice that the same current I1 and I2 passes through these two resistances. So these two are in series connection, because in series connection only the current remains same through all the resistances. So we are going to reduce this circuit into the following part. So 6 and 6, since these two are in series, directly adding up 12 ohms, and then we have a single resistance of 6 ohm like this. And now it is pretty much clear that these two are in parallel. So we'll find out 1 upon R equivalent, multiplying up and down by 2 upon 12 plus 1 upon 12 is equal to 3 upon 12. So 1 upon R equivalent is equal to 1 upon 4. So the equivalent resistance is 4 ohm. So here we go. This is the answer to the problem. So these two are in series and their combination was in parallel with 6 ohm resistance. Let's move on to the next problem. Here. Now this is very much clear that if you send some current through a battery connected across ends A and B, because you are supposed to find out the equivalent resistance between ends A and B. So some current I will flow and it will be splitted up into two parts, I1, I2. Now since splitting up of current takes place, that happens only in the parallel connection. So this is again I1, this is I2, same current combined together, I, again splitting up I1 and I2. Again these two will be combined together to form the same current I, and the same current I flows back in. So since these two are in parallel, I suggest that you simply write this as half of any one of the resistance, because if two resistances are in parallel, the equivalent resistance is half of any one of them. And you also need to remember one thing, that in parallel connection the least resistance is 6 ohm out of these two, right? Anyhow both are equal, and the equivalent resistance is even smaller than that resistance. Correct. So let's find out, just for your confirmation, R equivalent over here, 1 upon R equivalent is equal to 1 upon 6 plus 1 upon 6. So this is 2 upon 6, that is 1 upon 3. So reciprocating it, we get this as 3 ohm. So I'm going to reduce these two into a single 3 ohm resistance, and same calculation goes for this also. So again this is 3 ohm resistance over here. So reducing this to this one and this to this one, these two are in series. So we finally have a 6 ohm resistor, and this is the equivalent resistance of the entire circuit. So this entire circuit is actually having a combined resistance of 6 ohm. Over here again, now connecting the battery like this, some current I flows till here, which will be splitting up into I1 and I2. Now find out an easier way. You can see that whatever current goes up, the same current will pass through this also. So this I2 current will also flow through 2 ohm resistance, which is only possible if these two are in series. because in series connection the resistances are same. So these two in series, so I'm going to reduce this circuit into the following. So only one resistance, and in resistance we directly add up these two. So this is 3 ohm and this is now end A, correct? This one is end A, and you have another resistance of 1.5 ohm, and you can see that the ends of this and this are connected together, so this is end B. Now this is very much clear that this is a parallel connection, and I want to also write this as 3/2 ohm just for my easiness and solving the problem in an easier way. So 1 upon R equivalent, that is equal to 1 upon 3 plus 1 upon 3 upon 2. So that is 1 upon 3 plus 2 upon 3. So this is basically 3 upon 3, that is 1, and reciprocating it we get equivalent resistance as 1 ohm. So the entire combination acts as a single resistance of 1 ohm like this. With a battery you can call these 2 points as B and A. Moving on, so here the battery is already given, so whatever current I comes out, the same current I will pass through this, and from here the splitting up of the current into 2 parts takes place, I1 and I2. Now the same current I1 passes from here and from here also, and finally I1 and I2 join here to form the current I, which passes through this, and the same current comes back in. So these two are in series, so 7 plus 3 10, and that 10 is in parallel connection with this 10 ohm resistance. You need to be very careful while solving the problems, and then like this, these two are again 5 ohm resistors. Now 10 and 10 we know it is 1 upon 10 plus 1 upon 10, so 2 upon 10, so 1 upon 5, so reciprocating it 5. So I'm going to reduce this part. Let me do it for you. 1 upon R equivalent, that is equal to 1 upon 10 plus 1 upon 10, so this is 2 upon 10, so 1 upon 5, so R equivalent is equal to 5 ohm. So this entire part can be reduced into a single resistor of 5 ohm, and these two are already having resistances of 5 ohm each, like this. Now simply when you connect a battery, the same battery over here, whatever current comes out from here, the same current will pass through all the three, so the equivalent resistances are 15 ohm because all these three are in series, correct? So splitting up of the current takes place from here, so these two in series, and then its answer is in parallel with this, and finally whatever is the equivalent resistance of this part, that is in series with this and this one, that turns out to be 15 ampere. Now look at this good problem, right? Now this is A and B. I might want to rearrange this part, right? So I can bring this D point over here. You can do that. You can very well change the points, but you have to be careful that you need not to change the value of the resistances. You may also try to unfold it in this way, that's also allowed, and even pull it out. So simply this circuit, right, can be further, these two are the point E and C. Now I'm going to say this resistance as 4 ohm and this is point D, and then this as 8 ohm, like this, correct? And then these two are points A and points B, where I'm going to attach a battery afterwards. In the same way, this one is again 4 ohm and then this one is again 8 ohm, correct? Now you may just unfold these 2 points outside. That can be very easily done. So you can bring this B outside and A outside. So now these two are in series, and you may also want to connect a battery like this. So these two are in series, these two are in series, and its answer is in parallel. So 8 plus 4, 12. This is again 12. So 12 and 12 are in parallel. So answer is 6. So let me do it for you. This is 8 plus 4, 12. Again 8 plus 4, 12. So 1 upon R equivalent is equal to 1 upon 12 plus 1 upon 12. So 1 upon Req is equal to 2 upon 12, that is 1 upon 6. So R equivalent is equal to 6 ohm. That is the answer to the problem. So I hope that these kind of questions have helped you out. And if you have any doubts, please comment in the comment section. Thanks for